Okay, this is where we left off in class. We have x not less than or equal to -4. So if it's not less than and it's not equal, it's got to be greater than. So x is greater than -4. All right, and our domain is the negative integers, which means only negative numbers, only whole numbers. And so we want greater than -4. Well, those are going to be -3, -2, and -1. That's it. The only negative integers that are greater than -4. Example 86.4, negative x plus 4 is not greater than 2. If it's not greater than 2, it must be less than or equal to 2. And now we need to solve for x. So negative x is less than or equal to -2. And therefore we have to multiply by -1 and flip that sign. Don't do anything to it but flip it. Don't get rid of anything. Don't add anything. Just flip it. So x is greater than or equal to 2. And we're talking about real numbers here. So we can equal to. So we can put a dot on 2 because it can equal to and it can be greater than 2. So it's got to be all these numbers up here. Now we want to graph negative x minus 4 is not greater than or equal to -2. If it's not greater than and it's not equal to, it's got to be less than -2. And now we'll solve for x. So negative x is less than 2. And if we multiply both sides by -1, we're going to have to flip that sign the other way. So x is greater than -2. Notice I did not add an equal sign or get rid of an equal sign or anything like that. I just flipped it around. When we multiply by a negative number, we just flip the sign around. It's confusing because when you change a sign like this to not a not sign, then you do have to get rid of something or add something to it. You have to change that not greater than or equal to just less than, because that's the only thing left. But when you multiply an inequality by a -1 or a -2, anything negative, you have to flip the sign around, but that's all you do. Flip it, don't do anything else to it. So we want to know all the negative integers that are greater than -2, and there's only one of them, and that's -1. Irrational roots. Sometimes when you solve a system of equations, you can get answers that have irrational parts because you'll end up with a quadratic where you have to use the quadratic formula, and then you will sometimes get irrational roots. So that's all this is about. Solve it exactly the same way you would any other system of nonlinear equations. You're going to solve for y here because you cannot use elimination on this problem because you've got x squared, y squared in the first equation, and you've got y and x to the first power in the second equation. So you can't use elimination. You'll have to use substitution. So if we solve for y, we've got y equals x plus 1, and we're going to put that into the first equation for y. So x squared plus y squared, so x plus 1 quantity squared, and that equals 9. So I just took this value for y and plugged it in there. And when it says square, you got to square the whole thing. So now we'll multiply that out. We've got x squared plus x plus 1 times x plus 1. So x squared plus, got to FOIL this out, x squared plus x plus 1 equals 9. So 2x squared plus 2x. I'm going to subtract 9 on both sides, and I'll have -8 right there equals 0. I did that because to solve a quadratic, you have to get everything on one side and set it all equal to 0. So that's what we have to do because the way to solve a quadratic is to use the zero factor theorem. Before I try to solve it, I'm going to divide the whole thing through by 2 because it's got a factor of 2 in it and it'll make it simpler. So x squared plus x minus 4 equals 0. I just divided. Now to solve it, I can't factor it. It's not factorable, so I'm going to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is going to give me -1/2 plus or minus the square root of 1 plus 16, so that's 17 over 2. So that is the solution for x in this system of equations. I'm going to take that and plug it back into the linear equation to find out what y is. So there's negative 1/2 plus the square root of 17 over 2 and negative 1/2 minus the square root of 17 over 2. So there are two solutions for x. So there are going to be two solutions for y. So I'm going to plug those back into this equation right here. So for y is going to equal negative 1/2 plus the square root of 17 over 2 plus 1. And that's going to be 1/2 plus the square root of 17 over 2. So that's one possibility for y. If you put in the other value for x, you're going to have y is equal to negative 1/2 minus the square root of 17 over 2 plus 1, because up here it says that y is equal to x plus 1. So here y is going to be 1/2 minus the square root of 17 over 2. So your 2 points of intersection for this system of equations will be negative 1/2 plus the square root of 17 over 2 for x, and the y that goes with that is 1/2 plus the square root of 17 over 2. And then the other one is going to be negative 1/2 minus the square root of 17 over 2. And 1/2 minus the square root of 17 over 2 for y. And when you have irrational roots, they will always come in conjugate pairs like this. Negative 1/2 plus the square root of 17 over 2, negative 1/2 minus the square root of 17 over 2. So the x's are a conjugate pair. The y's are a conjugate pair. That's always going to be the way it is. Okay, let's remember that the slope of a line is going to be the difference or change in the y coordinate. So if you look at these 2 points right here, the y coordinate in the first point is 4, and the y coordinate in the second point is negative 1. So the difference in those, or the change in those two coordinates, is what I'm talking about, divided by the change in the x coordinate. So the x coordinate for the first point here is negative 3, and the x coordinate for the second point is 5. So for those y coordinates, the difference in the y coordinates, you're starting at 4 and you're going down to negative 1. So that's a change of negative 5. So that is in the numerator of your slope. Then going from negative 3 to 5, for the change in your x coordinates, that's going 1, 2, 3, 4, 5, 6, 7, 8 spaces to the right to get from negative 3 to 5 on the x-axis. So that is going to be your denominator for your slope. So the slope of the line through these 2 points is negative 5/8. So without a picture, the way that you could explain that would be that the slope of a line through any 2 points is the rise over the run, which is just the difference of the y coordinates, so 4 minus negative 1 in this case, over the difference in the x coordinates, the run. Negative 3 is where we start. We end up at 5, so negative 3 minus 5. So the slope formula is what this is. It's just a way of finding the slope without having to draw a picture. And all you have to do is just subtract your y coordinates on top in the numerator and subtract your x coordinates in the denominator. And that will tell you the slope of the line through those 2 points. The only tricky thing is you have to make sure that when you do subtraction, remember subtraction is not commutative. You can't subtract any order you want to. If you start with the coordinate in the first point in the numerator when you're subtracting your y's, you need to start with the x coordinate of that same point when you subtract your x's on the bottom. So I started with the 4 on top, 4 minus negative 1 for my y's. On the bottom, I have to start with negative 3. That's what goes with the 4. So make sure you're going from point 1 to point 2 or from point 2 to point 1, but don't mix them up. Don't mix up your x's and y's. So if we did it the other way around, if we started with point 2 and subtracted the coordinates in point 1, we would do it the other way around. So we would say negative 1. We start with the negative 1 for our y, and then subtract 4, the y coordinate from point 1. And on the bottom, we'd have to do it in the same direction. We'd have to start with our x coordinate in point 2, which is 5, minus the x coordinate in point 1, which is negative 3. And of course, no matter which way you do it, you get the same slope. You still get negative 5/8. It doesn't matter if you go from point 1 to point 2 or point 2 to point 1, but don't mix them up. That is the slope formula. The slope of the line through the points x1, y1, and x2, y2 is just m equals y1 minus y2 over x1 minus x2, or similarly, y2 minus y1 over x2 minus x1. So if you wanted to find the slope of the line through the points 2, negative 5, and negative 3, 7, you could do it one of two ways. So you could say m equals, I'm starting with my y's. Remember, the y's go on top. So negative 5 minus 7 over, now I have to start with 2 because that's the x that goes with negative 5. So 2 minus negative 3. And that would give me negative 12 over 5. So the slope for that would be negative 12/5. I could have done it the other way around. I could have started with the second point. I could have said 7 minus negative 5 over negative 3 minus 2, and that would give me 12 over negative 5, which is the same thing as negative 12 over 5. The slope of that line is just negative 12/5. We can do this problem the exact same way. We can say m is equal to the rise over the run. So the difference in the y's, 100 minus 57, over the difference in the x's, negative 5 minus negative 33. And that would give me 43 over negative 5 plus 33 would be 28. And that would be the slope of that line. We could do it in the opposite order. If I do that, I'm going to get negative 43 over negative 28, which is still 43 over 28.